Okay, good morning students. So we are going to see today module 2, that is analysis of structures, and this module considers problem dealing with the equilibrium of structures made of several connected parts. Okay, so already I discussed in the class, so further a small video for better understanding. Okay, so in analysis of structure model, what are the things we are going to say is we are going to consider the problems that are dealing with the equilibrium of structures. That is very important. Okay, and the structure is made up of several connected parts. Okay, next thing, several connected parts. So these problems call for the determination not only of the external forces acting, forces which hold together the various parts of the structure. Okay, so as I said in the class, so you are going to see the each member force, what it is acting. There is like B member, what is the force, and what is the force in the members CD and CB, and so each parts of the structure we are going to calculate the forces. Okay, that's fine. And after that, so we are going to see what is truss. Okay, yeah, truss is a structure composed of slender members joined together at their endpoints. Okay, so these are the structure. These are the structure members. Okay, and joined together at their ends. You can see that it is joined together at their ends. For example, this is member 1. It is joined here and here. Okay, that's the thing. So you know already we have come across roof truss and bridge truss, as I explained in the regular class. Okay, so you can see roof truss, most of them in the home or houses. Okay, they made by using this, or shed, normal shed, car shed or anything like this. And the bridge truss you have seen various places where their rivers are there. Most of them it is having this kind of structure. And the next one is to solve these problems in analysis of structures. The assumption, design assumptions are all loadings are applied at the joints. That is our consideration. So the forces are applying only on joints. We are not considering any other forces. Okay, and the members are joined together by smooth pins. Okay, so we are considering all these 6 points are having a pin joint. Okay, that's it. Smooth pins. Okay. Each truss member will act as a two-force member. So as explained in the class. Okay, so this member will have a two-force member. Here is one force and here is one force. Okay, are you getting? That's that. So therefore the force acting at each end of the member will be directed along the axis of the member. Okay, that's the thing. And next one is this one. So if suppose 3 members are there, so that is A, C, B, and 3 members are there. That is A, B, and C. Okay, P is the force applied. And if 3 members are pin connected, okay, just understand that word, pin connected at their ends. Okay, these are 1, 2, and 3 pin connected at their ends. They form a triangular truss. This is triangular truss. That will be rigid. Okay, you have to understand that word. This will be, this entire thing is pin connected and it will be in a rigid structure. If a truss is constructed by expanding the basic triangular truss, this one, okay, if you are expanding it, it is called as simple truss. So this one is called as simple truss. Okay. So next one is the first method, how to calculate the forces which are acting on the members. So the first method is method of joints. This method is based on the fact that if the entire truss is in equilibrium, already we have discussed, we are going to consider as a equilibrium. Okay. Then each of its joints is also in equilibrium. That one we understood. We have come across all the problems like similar to this. Okay. If the free body diagram of each joint is drawn, the force, this one is important, that is free body diagram. Okay. So anyway, we will draw and we will solve some of the problems. Each joint is drawn. The force equilibrium equations can then be used to obtain the member forces acting on each joint. The important thing is, in this method, the entire truss we are considering as equilibrium, and each of the joints also we are considering as equilibrium. After that, we are going to draw the free body diagram of each joint. Then the force equilibrium equations we are going to find out, and from that equation we are going to calculate all the member forces of the truss. Okay, this is called method of joints.